Hi folks, today I don't bring you a new panel, but rather a slight different version of the already famous KMM3000. Today I just want to focus how to connect this version, which is a little different but simpler to do. These two versions are present in the market simultaneously, in this case one served Meo and the other Vodafone, which are internet and pay television providers in Portugal. I like that these two panels are located on devices that are sold throughout the world by different operators. They are easily available for sale in the web. I use exactly the same code as previous for testing purposes. The code supports the tests of the buttons, for example. Center, up, down, left, 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 right, right, right. The infrared is also read by the infrared receiver, but I don't have the command to the decoder implemented. As you can see, I connect the wires direct to the PCB, but you can use the satin, okay, the header of the 20 pins. In this case, the space is 2 millimeters, okay, is not the standard 2.54, is 2 millimeters. And I like you pay attention to the orientation of these ICs, because is the first way to check the difference between the both panels. You have here a different version of the panel, and the board is more short, and also the orientation of the chips are different, and also the connections are different in both panels, but the remaining part is equal. If you have one board of this, you can also use the same code and do it the same operations with it. To connect the panel, we use header of a satin cable with 20 pins, 2 rows of the 10 pins each. This is the identification of the pins, and you can find here, for example, the clock, in this case SCK, MOSI, MISO, GND, DSS, filament 2, filament 1, another GND or VSS, a VDD, in this case is the plus 5 volts, and here you have the negative voltage to the filament and the grids. Because the panel have a transistor to control the reset pin of the atmega, is necessary invert the signal coming from the UTK 500, the device I used to send the code to the panel. Of course, if you don't have the device UTK 500, you can use Arduino as a ESP provider, okay? It's not difficult to do it. The processor present in this panel is the 8MB88, and the driver decoder to the VFD is a PT6302. I like remember this driver have the internal table ASCII which allow send direct the message in the text format. As you can see, the filaments have bright, and you don't see shadows around the segments. Stay off. Because I'm using the DC voltage to power up the filaments, it's necessary to take account the orientation, the positive and negative of the filaments. If I invert the voltage from the plus to the negative, you stay with a lot of shadows in the segments. Stay off. Okay? This is not a problem. This is a result of the polarization of the filaments with the DC voltage. I will not spend time talking about the code because the code is available a long time ago. Today I will try to explain how program the 8MB88 through the platform Microchip Studio. We go to the tools, select device program. In this case I have STK 500 connected to the PC through the serial port COM4. I select. I already select the 8MB88. I want to use the ISPico connection, in this case interface. I make the apply. I make the read of device signature to have the sure the communication with the processor is available, and after I press the button to send, and I receive the message of the succeed to upgrade the processor. This software or this code is related with 8MB88, but if you want, you have also the 8MB328 available to proceed with upgrade of the board. That's all.